So this is a past IB chemistry exam paper 2 question, and in this question it says the graph below shows pressure and volume data collected for a sample of carbon dioxide gas at 330 K. So K is an SI unit for temperature, and which stands for Kelvin. And the first part of the question says draw a best fit curve for the data on the graph. So first of all, in order to answer this question, you have to know what a best fit curve is. So a best fit curve is one that goes through most or all data points on the graph and is as smooth as possible, and shows the relationship between pressure and volume in this case, or on other graphs would be the relationship between the y-axis and the x-axis. So this would be your answer for this graph, because it goes through the most data points. It doesn't always have to go through all, because not all graphs are extremely accurate. Sometimes it can be a little bit inaccurate. So in this case it goes through most data points, and it's as smooth as possible, and it shows the relationship between pressure and volume. And also it can be any other it can be in any other form, because any other form would be incorrect. For example, linear would be incorrect because it only passed through 2 points, and it wouldn't best show the relationship between pressure and volume. Now the second part of the question says deduce the relationship between the pressure and volume of the sample of carbon dioxide gas. So the key term here is deduce, because deduce is an IB command term, which means to use all the information given in a question in order to find an answer. So in this case, all we're given is a graph. So if you study the graph carefully, you're going to find, let's say if you study the first point, you're going to find that on the x-axis for volume, it was at 50, and then it doubled to 100. When it doubled to 100, the y-axis halved. So as you can see, if you round this up to 20, it halved from 20 to, if you round this up to 10, so from 20 to 10, or from 21 to 11. So it halved. And then if you look again at this point, and then at this point, you're going to find that 100 doubled to 200 on the x-axis for volume. And then for the y-axis, it halved again. So if you round this up to 10, you're going to find that it halved to 5. So this means that this is an inversely proportional relationship, because when x doubles, y halves. And as you can see, this is usually what it looks like, which matches our curve of best fit, because our curve of best fit shows the relationship between pressure and volume. And also this can also be a negative correlation, because as the x-axis increases, the y-axis decreases, as you can see on the graph, which is this. However, in this example it's linear. In this case it's not linear, so it's a negative correlation, because when x increases, y decreases. So your two acceptable answers for this part of the question is inversely proportional and negative correlation. And then the last part of the question says use the data point labeled x, which is this one, to determine the amount in mole of carbon dioxide gas in the sample. So we're using mole in order to find the amount of carbon dioxide gas. Now the important thing to know is this whole graph represents a sample of carbon dioxide gas, and we're trying to find its amount in the last question, the amount of carbon dioxide gas represented in this graph. So in order to do that, we're going to have to know the ideal gas law, and the reason for that is we're dealing with carbon dioxide gas, which is a type of gas. Therefore, we need to use the ideal gas law. So P here stands for pressure, V stands for volume, N stands for mole, which is what we're trying to find, and R stands for the gas constant, the ideal gas constant, which is 8.3145 joules, times mole times K, which is a unit. And then T here stands for temperature. Now we need to find N. So in order to do that, we have to isolate N. So take PV equals nRT, and then we isolate N. So in order to do that, we're going to divide this side by RT and this side by RT. And then N would equal PV over RT. And then what we have to do now is isolate. Substitute in the terms. So if you look on this side to the graph, we're going to find the graph here, and we have to isolate. So P is pressure, as we said, and it says to use this point, which is X. So the pressure here is 21. So you put in N equals 21. However, if you look at the label, it says pressure times 10 to the power of 5. So it's 21 times 10 to the power of 5. And then times, if you look at the formula here, it's N equal PV. So P times V, which V is volume, so it's pressure times volume. And if you look at the point here, you're going to find that the volume is 50. So it's times 50. And then if you look at the label for volume again, you're going to find that this volume is multiplied by 10 to the power of negative 6. So 50 times 10 to the power of negative 6, and then over R, and as we said, R is the ideal gas constant, as you can see. So we substitute that in, which is 8.3145, and then times, because it's RT, so R times T, temperature. And as it said in the beginning of the question, that the temperature is 330 K. K is the universal SI unit for temperature, so it's times 330. So N equals, so 21 times 21, so 21 times 50, 21 times 50 equals 1050. So 1050, and then times, when you multiply exponents you add them, but in this case you have a negative 6, so 5 plus minus 6 would be 5 minus 6, which means times 10 to the power of negative 1, and then over, so 8.3145 times 330 would equal 2743.785. So N equals, and then you notice that we have the negative 10 to the power of negative 1 here. So what you want to do with that is, you want 10 to the power of negative 1 means to move this decimal place right here to the left one time. So this means 105 over 2743.785, and then N would equal, and 105 divided by 2743.785, which equals this amount. However, we're gonna round it up to the least amount of sig figs in this equation, because when multiplying or dividing you get the least amount of sig figs in the equation. In this case, the least amount is three significant figures, so it would be 0.038, and this would be your final answer for part C of this question, because 0 counts as a significant figure because it's after a decimal point, and these two are non-zeros after also a decimal point, so they all count as sig figs. So this is your final answer.